Hi guys, welcome you all in another session of AI/ML. So we are going ahead and starting with another form of it. Like basically, we are going ahead and starting another session related to AI/ML from where we have just taken a leave. So let's just get into it. So just a moment, guys. Okay, guys. So let me just share my screen. So I'm facing a bit network issue. Just a moment. Guys, can you just see my screen? Is my screen visible? Fine. Let me just check it again because it's not visible me for either. Like though I have presented it, it's showing presented but not seen. Just a minute, guys. Let me fix this. Okay, fine. Hopefully now it is visible to you. Let's just go ahead directly with the problem. So in the last session, we have just gone ahead and discussed about the regression part, like classification as well, and the regression we have already covered, right? So here we will be just understanding how we can just using Python, how we can just make a model that will be understanding the pattern based on the data set, and based on that, it will move ahead. Okay. So basically, what we are doing here. So the problem that we are solving is like we want to predict the salary based on the years of experience. Okay. So if someone has 1 year of experience, then the salary is around 30,000. Right here, you can see that experience is one, salary is 30,000. Experience is two, the salary that is coming up around 35,000 for salary. For 3 years experience, it is going out around 40,000. For 4 year experience, it is going out around 45,000. For 5 years, it is coming out to 50,000. Likewise, it is moving. Okay, so basically, what is happening up here? So, we want to predict the salary based on the years of experience. Okay, so if a person has about 3.5 years of experience, how much salary would they get? Right, this is exactly what linear regression does. Okay, so we'll just recapitulate a bit about linear regression, then we will move ahead. So, regression does a straight line that best fit the data. Okay, so you can think about like x-axis, that is years of experience. Like along x-axis we are going for years of experience, and along y we are going for the salary. Okay, now I want to draw the best straight line that connects the dots accordingly. Okay, so that line actually show this rule as salary equals to, like, let me just write it somewhere so that we can just get a better idea about it. Yeah. Okay, so we are just writing it likewise, like we are writing it as salary. That would be equal to slope into years of experience. Then we are just doing the operation, like we are just adding that up with intercept. Okay, so this is our equation altogether. So let me just raise it. Okay, this basically I want to raise it, and I want it in middle, and I'll just want it. Okay. So you can see here. So how to calculate the salary based on the years of experience? We have the salary that would be equal to slope into years of experience plus the intercept. Okay. So what are the steps that we need to follow? We need to collect the data. We need to separate the inputs, that is the experience, and the output, that is the salary. We need to split the data into two halves, that is the training data and the testing data. Training data is for learning basically, and test data is for checking, like is it predicting well or not. Now training the model, or like learning the pattern basically, then going for predicting the salary and check how good the prediction is. This is all we want to do. Okay. Now coming down to the code here. So first we have imported the libraries. We have imported pandas as PD. So panda is like the smart Excel table, you can think. So it helps us to store and work with the data easily, right? Suppose you have a notebook with rows and columns, Panda actually helps to manage that. Okay. Now going ahead, we have sklearn.model selection, import train test split. So we want the train test split that actually help us to split the data into training data and testing data. Like you are supposed studying from one notebook and giving an exam from another notebook, like that. Okay. Now coming down, you have from sklearn.linear_model import linear regression. So linear regression is the model that learns the straight line, like that fits to the line accordingly. So that is the model. So we want that model because we want to train our model with this linear regression model. That's why. Coming down to sklearn.matrices, import, that is mean squared error and R2 score that we are doing. We are checking how good our model is. So that is the part we are doing. Now we have to create the data set. Okay. So with instead of importing the data set, we have just created a data set and want to just take the data accordingly and need to understand how it is moving accordingly. Okay. So we are just going for an example data set. So here in the example data set, you have got the data. Like we have given the name as data, and here we have used a dictionary format. In dictionary format, we have taken it. So you can see the years of experience we have kept in a list, that is 1, 2, 3, 4, 5, like that, and the salary accordingly. So years of experience and salary are the keys, and the values that are there. That is 1, 2, 3, 4, 5. That is the values for the key years of years experience. And salary is the key for the values as 30,000, 30,500, like sorry, 35,000, 40,000, 45,000, and 50,000. Okay. So this is my small data set, as you can see. Now we have just included it in the data frame. Like we have converted the data into table format, right? Just like we have the data in the Excel. That is why we have just converted into data frame. Now we had to separate the input and the output. So we have taken along X, DF, we have taken the input. So X is equal to input. What we already know, X is of course the independent variable. That is what we already know. That is years of experience is known to us. We want to predict the salary, right? So by double bracket that we are using because ML expect input as a table, not as a single column, right? So that's why we have used this double brackets. Like here you can see this double brackets. Okay. Now we have included y equals to output. So we want to predict the salary. So along y we are going for output. This is the dependent variable, dependent on what? Dependent on the years of experience. Okay. So now we have split the data accordingly. So we have the variable as x train, x test, y train, y test, and we have used the train test split. We are splitting what? Splitting the x and y. This is x and this is y that we are splitting, and we are keeping 80% of the data for training, and the remaining 20% we are keeping for the testing. we are going for the testing positions, okay, like the testing purpose, okay, like suppose from 4 question, 1 question will come in the test, so like that kind of setup, okay. Now, what we are doing, we are going random step equals to 4. That is actually keeps the split same every time. Okay, like fixing the seat arrangement that you can see, right? So it will be splitting. It will keep the split every time the same. Now, this is going down for training the model. So we want to create the model first. So what is the model basically? We want the linear regression. We have to train the model based on linear regression model. So this model equals to linear regression. This create an empty brain like that you can think of, and that doesn't know anything, right? Now we are going to train the model. So model dot fit with X train and Y train. So this is the learning time basically. So the model actually learns how salary changes when the experience increases. So this finds the best straight line. Okay. Now we are going for the prediction. So here you can see we have used y predict equals to model.predict x test. So the model now looks at the experience and predict the salary. Okay. Now I want to see the equation. That's why we have checked the performance. So we have got for the slope value we have taken. Next, the intercept we have taken R2 score and the MSE. After running this is our result. Okay. So this is the result we have got. Now, basically, what this is actually signifying. The slope we are getting is around 5,000. So slope, what is mean actually? Slope means like how much salary increases when the experience is getting increased by 1 year. Okay. So here, the slope is saying the with the increase of 1 year experience, the salary is increased by 5,000. So the computer learns this rule that with increase of 1 year, the salary is getting changed by 5,000. Okay, that is increased by 5,000, not change. Like what is the base salary? With that 5,000 is getting added so that you are getting 5,000 more. Okay. Now the inside basically that you are getting, this model understood the pattern correctly, and the salary increases equally every year going from 1 year to 5 years. Okay. Next, we have the intercept. Intercept is going at around 2,000 25,000. Intercept is going as 25,000. So this means the salary with experience zero. Okay. So according to the model, if someone has zero experience, the salary would be around 25,000. This is makes the sense basically. If your data starts from 30,000, increasing 5,000 per year, then it should go, if it is going back around a year, that is around like 0 years, like with a fresher, they should go get a salary of 25,000. Okay. So the model found a logical starting salary. The line equation would be correct. The line equation is, of course, for if we are taking the slope as 5,000 and intercept as 25,000, in that case, the equation basically, not the slope. The equation is coming up as salary that is equal to 5,000. That was equal, like that we need to into with years experience, and I want to just add it up with 25,000. Okay. So this is what we want. So we will be just increasing it like that, and we'll put it here. So this is my equation. This is the equation that is coming. Now, if this, suppose the years of experience is coming up to 4, so it will be around 5,000 into 4 plus 25,000. So that is coming up around 45,000, right? So now this is the prediction that model will be doing based on this formula. So for 4 years, the experience is 45,000. Now going here, if I am checking the data for 4 years, I am getting this salary range as 45,000, right? So this exactly matches my data. Okay. Now coming down to R2 score. R2 score is none. Okay. So what is R square score or R2 score, whatever you call it? So R2 score is actually how good my model is predicting. So R2 value, if it is 1, then the model is going perfectly fine. If it is 0, then the model is unable to understand the intricate details and the pattern, and it is not doing it accurately. Okay. So now, what is it? What is this NaN? It is in place of here, we are getting NaN. So why we are getting NaN? That is, I cannot calculate it. This is the thing that it is meaning, right? Because because you have tested the model only on one data point, right? So you can see that what is the total data, the number of rows that you're getting. So that is 1, 2, 3, 4, 5. So 5 rows you are getting. So the test size is 20%. So only one sample, suppose you are going for one sample. So R2 needs at least two test point to compare the prediction basically. Okay. So it's like the teacher gives you one question and say compare your marks and marks with the class average. That is impossible, right? So that is the case. So R2 score is not working wrong. It doesn't mean that it's not working wrong. The data is too small. That's why the model is not taking it like that. But the model is actually perfect because we are getting the MSE value as 0. So MSE means how big the prediction mistake is. If MSE value we are getting as 0, that means model made zero mistake and the prediction is equal to the actual value. There is no difference in the or no mistake you can see that that is there inside the actual value and the predicted value. Okay, so suppose my actual salary like that we are putting here is 40,000. My model is also giving me the prediction salary as 0. So the difference is 0 and the square difference is also 0. So the model predicts it perfectly and the straight line fits exactly. Okay, all of the points accurately. And of course, this is the warning part. So it is not like my model is not working or there is a coding issue. The test data is too small, so that is why we are getting this warning kind of thing. Okay, warning message. So the overall insight is that the model learns perfect patterns. The salary increases by 5,000 per year. There is zero prediction error that we are getting, and the correct line equation we are getting. Okay. The only major mistake that we can got, that is we haven't got the R2 score because of the lesser test. The data that we have taken, that is too less. So if we can increase the data, we will be definitely getting the R2 value as well. Okay. So this can be fixed by using more data, by using the test data as well. We can just take it accordingly. So this is the part of a linear regression. Okay. So we have already discussed about linear regression, but there the model was unable to perform well, right? If you can remember the problem there, the model was not performing well. We have got around suppose 30 to 40%, 30 to 40%, or majorly the MSC value was too long, right? Too huge, basically. That is the reason the values are not taking appropriately. So we have taken this data again, and we can see that here the MSC value is 0. That means the model has learned exactly the right way, and there is no issue with that. Okay. So we can just also do this using a data set. We can just import the data set, and based on that can just change the data frame using that, and based on that we can just perform the linear regression on that data as well. Okay. Now coming down to the logistic regression. Before going down in details, we need to understand what is this logistic regression, because we have already discussed the classification in details, right? In the last session, we have discussed about classifications in details. Now logistic regression is a model that comes under classification. Like under supervised learning, we have got regression and classification. So logistic regression is coming under the classification kind of problem. So we need to understand it first, then we will be moving ahead. Okay. So let's just discuss about logistic regression. Okay, fine. Yeah. So logistic regression is yes or no decision maker. Okay. It answers question like, will it rain today? Is this a email spam? Did the student pass the exam? Is it a tumor cancer or a non-cancerous? Is it a malignant or a benign tumor? This kind of answer it is giving. Okay. So like logistic regression is used when the answer has only two choices, like a binary classification, one is yes, another is no, right? So simple example, we need to just take it up so that you can understand it. So the very first one is, so will you pass in the exam or not? So things what will matter for this will be hours of study, the sleeping hours, and the class attendance. Okay. So we are putting this all of these features like study hours, next the sleeping hours, the class attendance, all this we are putting is an input or the feature you can call, and in return the output or the result that I'll be getting, that is pass or fail. Okay. So only like we are getting only two answers up here, either yes or no, or pass or fail. So it is a binary classification problem. So why not we are using linear regression? Linear regression actually giving the answer in a continuous data form. Like suppose it is 120, 100, minus 5, 1.5, like this we are getting. But yes or no, in that case, we need the value as either 0 or 1. Right. So linear regression cannot go outside 0 and 1. That is the case. Like can't give the only output as 0 and 1. That is the reason we need to include the logistic regression. Here we will be getting the output as either 0 or 1, and the result will be staying, like whatever the result that will be staying within 0 and 1. So based on that, we'll just create a threshold for that. We will be getting the prediction like that. Okay, so let's just understand about it in details. So what is logistic regression? So it actually calculates what? Calculates the probability. Probability that is, suppose I have got the probability of 0.90, that is 90% chance of pass. Then we have concluding it to be yes. And if the like probability is coming out as 0.20, then 20% chance of pass. That means the person will fail. Okay, so this is the idea basically. So now logistic regression actually calculates the probability, then decide is it yes or no. Hopefully you have understood what I am trying to say. Okay, now first we need to do the weighted sum like the linear regression how we have done. So we will be doing as z equals to w1 x1 plus w2 x2. Okay, fine. This should be W1 x1, W2 x2 plus W3 x3. Like that, it will move and we will be taking it like that. Okay. So basically, X is the input here, like the hours of study, sleep, attendance of the student, all of this. And we have W. W is the importance. How important that input is, that we are putting plus B, of course. Here we need to add plus B. So plus B is the bias, that is the extra push, and Z is the final score. Okay. So here we have got the features, that is hours of study. Suppose the hours of study, in that case, we are getting the value as like here, let me explain. So hours of study, here we are getting the result as suppose 5. Next, we have the sleep hour, that is coming down to 7. And next, we have suppose attendance. that is coming out around, suppose one, let's take the study hour as a bit less, that is 5, 7, and 1, like that. Okay, so hopefully things are visible to you. Let me just put it like this so that things are clearly visible. Now let's just take it in this way. So basically, I want to get the weights. Suppose the W1 we are getting as 0.5. Next, W2 that we are getting as 0.2, suppose, or 0.3, maybe a bit more. And W3 that we are taking as 0.2, and B value we are taking as -4. Okay, now we need to just take it accordingly. So take it accordingly means like we need to calculate it accordingly to get the Z value. So Z would be equal to 5 into 0.5. Next, we are just adding and getting 7 into 0.3, plus we are doing as 1 into 0.2 that we are doing, and we are doing -4. All right. So we are getting 2.5 plus, okay, plus 2.1, 2.1 plus 0.2 minus 4, minus 4 we are doing, just a minute. So minus 4 we are doing, then I am getting the result as 0.8. Okay, so Z equals to 0.8, but this is not a probability yet. This is the Z, just the value of Z. Now we will be using what? We will be using the sigmoid function. We will be using the sigmoid function to get it accordingly. So sigmoid function is like to want to convert this Z value, because this Z value is 0.8. So we want to convert this between 0 and 1. Okay, so we use this sigmoid function basically. Okay, so for that the value is the equation is 1 by 1 plus e to the power minus z. So if the z value is big positive, that is closer to 1, if the value is 0, then we have the sigmoid output as 0.5, and if it is negative, then we have the value of sigmoid closer to 0. Okay, now here we can see that z equal to 0.8, then giving the sigmoid value, the sigmoid is 1 by 1 plus e to the power minus z. Okay, so the same thing, 1 by 1 plus e to the power minus 0.8 that we need to do. So that will give us the value as 0.69. Okay, 0.69. So that means that is 69% of chance, 69% of chance of the student passing the exam. Okay, so that means now we have to make the decision. This is the probability that we have got, that is 0.69. Now we need to take the decision. So what would be the taking the decision? Here we need to create a threshold. So if probability is greater or equal to 0.5, then we are getting the result as yes, that is equal to 1. If not, if this probability that is going less than 0.5, then in that case we are getting it no, that is the student won't pass, and we are getting the result as 0. Okay, so 69% probability, so the decision would be of course pass, because it is going a good, like it is 69 is going greater than 0.5, so the decision would be pass. Okay, So here basically how we are going, we are using inputs, then we are doing the weighted sum that is going for the z value, calculating the z value. Then we are using the sigmoid operation, and then we are getting the probability. Then from that probability, we are putting a threshold to make a decision if the student passed or failed. Okay, so this is what it is. So now we have included, this is the entire concept of logistic regression. Then we have the errors. Errors is basically coming out with the loss formula. Okay, so we actually measured how wrong it is using this log loss. So that is the correct prediction. We are getting the smaller loss. For the wrong confident prediction, we are getting the bigger loss. That is the exact part. Okay, so now coming down to the training process, we'll guess the weight, we'll calculate the output, we'll calculate the weight, like calculate the loss basically, the error that is there that we will be calculating. Based on that, we will be update the weight and repeat it multiple times till it not run accurately. Okay, so logistic regression is basically what is logistic regression? Let me just write it down. So logistic regression, if we can take understand the pattern, so it is basically linear regression plus sigmoid plus threshold gives us the logistic regression. Linear regression plus sigmoid plus threshold give us the logistic regression. Okay, now we'll just move it here and we'll go down to understanding of the logistic regression. Okay, so basically here what we have done, the same thing, we have imported the libraries and we have taken the data set. We have taken the data set as data equals to study hours that we have taken up. So that the study hours that we have taken up as 1, 2, 3, 4, 5, 6, 7, and based on that we have basically taken the hours like the passing rate as 0 and 1. 0 means the student didn't pass and 1 means the student has passed accurately. Okay, so basically 1 for 1 hours of study the student failed, 2 hours of study student failed, 3 hours of study student failed, 4 hours of study student passed, 5 hours of study student passed, 6 hours of study student passed, 7 hours of study student has passed. This is the thing. So why we are not using the linear regression? Linear regression gives us the numbers, just like the salary, 50,000, 60,000, 80,000, right? But here we won't be getting the value within the range of 0 or 1, pass or fail. So we want the result as 0, 1 or 1 as we have given the output, but this won't be getting. So that's why we have shifted to logistic regression. Okay. So basically what we will be doing, in regression, we will be making the decision based on the hours of study, how confident that the student will pass. Okay. So first, as I have given you the example, it will give me the probability. So if it is the value is going down near to 0, then it will fail, and if the value is near to 1 it will pass. So we'll keep a threshold of 0 0.5. If the probability after applying sigmoid we are getting as 0 0.5, the student will pass, else the student will fail. Okay, so now here what are the steps we have used? We have just given like the model where the data set, we have separated the input hours and the output. Basically we have separated the input and output, basically splitted the data into the learning and the testing form. Next, trained the model and make the prediction and then check the accuracy. This is what we actually wanted up here. So the same thing as we have done in linear regression, we have taken an example. So after first we have taken the libraries accordingly. Here we have initially we have taken here the linear regression, but here we will be needing the logistic regression. That's why we have taken. And for the matrix, we have used the accuracy and the classification report that we have taken. Now we have the example data, the data set we have taken and the example data. Now we have just get the features and the target basically. The features and the target means like we have separated the input and the output. So the study hours is my X. So what we already know, that is the independent variable, that is the hours of study. And why we have taken that as the output that we want to predict. Okay. Now, as discussed, we have split the data and we have kept 20% of the data for testing purpose and rest we have gone it for the training. Next, we have created the model, like we have used model equals to logistic regression, and we have model dot fit xtrain and y train because the model need to give with the labels. So y train contains the labels and x train is the data, like the hours of study, and x test and y test contains the data that we will be going for the testing purpose. Okay. Now going for prediction, after making it like after giving the data to the model, we want to go for the prediction after it has learned. So y predict is equal to model dot predict equals to x underscore test, because why, when we will be going down to in the testing the data, in that case we will be giving the value as x test, right? Why we are giving x test? Because x test is my input and the output we will be, my model will be predicting, right? The output I'll be predicting, and y test contains the actual result. Now once model has predicted something, I have to just get it accurately so that I can compare the actual value with the predicted value. So I'll keep the y test accordingly based on the X test, right? So we have got that, and after that, we are going ahead with the details. Like we want to take it accurately, fine. So now I want to test the performance. I want to test the performance. What is the performance that we have? So we have got the accuracy and we have got the prediction. So the model has predicted as 0 means the student will fail, and the accuracy, of course, we are getting the result, the actual result as 0 only. That is the reason we are getting the accuracy as 1. Accuracy is 1 means the accuracy is 100%. That means the model is learning well, and based on that, the model is going well. There is no issue with the model that we are going. Okay. So this is the details about logistic regression. Now we have the ridge regression. So basically, what is there? We have got the area, the room, and the price. So we want to solve the problems. We want to predict the house price based on two things, that is area and the room. Area is in square meter and room would be in number of number of rooms. Okay. So the input is area and room and the output is the price. Okay. So now here what we are doing here, we are trying to include the ridge regression. Okay. So here basically based on that, how my result will be, like how my equation will be. So let's write the equation. So it will be price. Price is my output, that is y. So it will be some number like any of the weight basically. Weight into area. Now I want to sum this up. Okay, what is sum? Sum this up with weight 2 into the rooms that feature we are having, plus I want to do intercept. This is the form that I'll be getting. So why ridge regression? So normal linear regression contains a problem. Okay. So if we have few data points or the data is noisy, linear regression may give a wide, large number of coefficients. Okay. So that is actually overfit. It actually learns too perfectly on the tiny data that we are having. Example is like the model that says the price jumps too much if the area increases by 1 unit, right? So for this problem, we have got the the answer of the solution. We can say that is ridge regression. So ridge regression, what it does, it adds a penalty for large number, that is the coefficient. So that makes the model behave nicely. Okay, it stops the model from becoming too greedy and helps the model predict better for new houses. Okay, so that is the part we have done. Now here in step by step form, what we have done, we have just given the model the example of the houses that contains the area, the rooms, and the price. And we have separated the features. We have to separate the features as we have done in logistic regression and linear regression, like the separate features, that is the independent variables. The X will be contains area and the room, and the target or the Y, that is the output, will contain the price. Then we'll split the data into train and test, and then train the ridge regression model that will learn the coefficient but with a penalty, right? But with a penalty. So then we will go for the prediction price of the test houses. Then we'll check how good the predictions are using the MSC. Okay, so this is what we want to do. Now here you can see the similar thing. We have imported the libraries. Here we have used Ridge because we will be using the Ridge regression model. The same thing, example data set we have taken features and target we have separated along X. We are taking area and room, and Y we are taking the price. Now we have gone with splitting the data and kept 20% of the data for the testing. Now we have created the Ridge regression model. Ridge model we have kept Ridge with alpha equals to zero point 0.1. Alpha is the penalty strength. Okay, so we are keeping alpha as the penalty strength. So bigger alpha, the model is more disciplined, like the coefficient would be more smaller. Smaller alpha is like the model behaves closer to the normal linear regression that we already have. So we need to take this alpha value accurately, not too high, not too small. So like that we have to take. So for now we have taken it 1. Okay, now we have trained the model. So once we have trained the model, so that will give us how area affects the price and how rooms affect the price. The coefficient are learning, but the penalty prevents the huge jump that we are taking. Okay. Now we are going for the prediction basically. So prediction is predicting price on the test houses, and example is like suppose we are taking the area as 80 and the rooms as 4. So it will predict the price based on that. Okay. Now we are checking the performance. So the predictions, we are getting the coefficient, we are getting the intercept, we are getting, and the MSC we are getting. So for here predictions, that is the predicted price is 175.70. So that is the price of the room or the flat, whatever be it, house price basically. Now coming down to the coefficient, coefficient is the value of this W1 and W2 that we have taken, and these are the these are the values accordingly, and the intercept value is 11.280, and the MSC value is coming up around 18.459. That is not that huge, but also the not that small also. So we can understand like around or like 90%, 98%, the model is 90 to 95%, the model is doing good, right? So there is no issue with that. So what exactly we are doing up here in case of ridge regression? In ridge regression, we are doing the linear regression plus we are adding the discipline. Okay, that stops the model from going too wild. It makes the prediction more reliable, and we use alpha to control the penalty strength. So this is the part we are doing. So we can claim that this model is learning good. The MSC is value is not exactly what it is, but the mistake or the error that we are getting, that is not too high. Okay. So this come down about the ridge regression. Next, we will go down for lasso regression. Okay, that is L1 regularization. So here we are solving the problem. Here we want the house price using the area and the room. The same example we have taken. Here in place of ridge regression, we have included the lasso regression. Okay, so we will be calculating the result also later. We will be comparing each one of it. Now here the input is the features. Input features are area and room, like just like the uh, ridge regression, and the output is the target. So why not we are using the linear regression here? The normal linear regression actually tries to draw a straight line to fit the data. But sometimes what happens, some of the features are not that very much important. Like the rooms may not matter that much, right? The model may overfit in that case. That learns the tiny mistakes in the data. And the coefficient, like the number multiplied with the features, that is W1, W2, that may become too big, right? So we need a method that prevents the overfitting and ignores whatever the unimportant features that we are getting. So lasso regression is like the least absolute shrinkage and actually the selection operation. Okay, that is the whole name of lasso. Lasso is least absolute shrinkage and selection operator. So simply it is like linear regression plus penalty plus we are having this feature selector. This feature selector part is not there in case of Ridge. We have this feature selection part in case of Lasso. So penalty is like preventing the coefficient from getting too big, and this feature selection can make some of the coefficient exactly zero. That has no major effect in the data. Okay, it ignores the unimportant features. Okay. Now coming down here, basically what we are taking, we are giving the data to the model. We are separating the features based on X and Y, that is input and output, splitting the data, training the model with lasso regression, and then predict the price of this test house, and then check how good the prediction are using MSC. Okay, the same thing we have done, the same example, the same everything. So just the differences in place of in place of lasso, in place of ridge, we are using lasso. So here we have used lasso regression and included the alpha, that is the penalty strength to be 0.5. And then we have done like fitted the model with the X train and Y train, and then gone for the prediction with the lasso model and check the performance. The prediction is 1755, that is the predicted value. The coefficient we are getting like this, like the house price is way too less, that's why the you can see it has gone it up with zero, and then we have got this intercept and MSC. Now comparing this, the MSC value is 18.4597, and here the value is 18.1234. So for lasso, the loss or the MSC, what is the error, the squared error, the error part is way a bit lesser than going down for ridge regression. Since we have taken a small data set, it has not impacted that much, but we have seen a bit improvement in the error part. There is a bit lesser error when we have used the lasso regression model, right? So this is all about the linear regression, the logistic regression, the ridge regression, and the lasso regression. In the next session, we will be discussing in details about some other classification-based problems. Today, for the classification-based problem, we have only discussed about logistic regression. This ridge regression, lasso regression comes with the regression, solves the problem of the regression types of problem, not the classification. So, in next session, we will be continuing from here and discuss some of the classification based problems. Okay, so till then we will be continue keep on practicing on this so that these things become very clear to you, and we will be connecting in the next session accordingly, and then we will be starting it up from here. Okay, so thank you everyone for connecting today. We'll again connect in the next session accordingly, and we'll continue from here. Okay, so thank you everyone. Bye guys.